Hey, welcome to today's lesson. Up to now, we've just been manipulating trig expressions. We've been given this cumbersome, bulky expression involving trig functions, and we've just been playing with all of our knowledge of trigonometry to kind of clean it up, simplify it down to a single expression or a much more simplified expression. But today, our lesson is on solving equations that have trig functions in them. So the difference today is by the end of our problem, we're going to have an actual value of x that if we plug that value back into the equation is going to give us a true expression. So your guided notes aren't here. You are taking notes on your own. Be sure to pause the video and take quality notes so you know what's going on. So to start out this problem, I'm going to do everything I learned in Algebra 1. And what I learned in Algebra 1 is I want all my expressions involving an x on one side and all my constants without an x on the other. So I think the quickest way in this case is to subtract the sign of x from both sides. And on the left side, I'm left with a radical 2. And on the right side, I have negative 2 times the sign of x. Now, I'm not done. I want to get the x by itself, so I'm going to start undoing things that are happening to it. So I'm going to get rid of this negative 2 by dividing both sides by negative 2. And I end up with this. The sign of x equals negative radical 2 over 2. And this is where we veer a little bit off of what we've done in algebra. Once you get your trig expression all by itself, just the trig expression, nothing in front of it, just the trig expression, I'm going to go to the unit circle and I'm going to logic my way through this. I need the sign to be negative, and I know the sign is negative in quadrants 3 and 4. I need the sign to be a negative radical 2 over 2. And I know from my unit circle values that radical 2 over 2, that's a bisecting angle. And so in quadrant 3, that bisecting angle is 5 pi over 4. And in quadrant 4, that bisecting angle is 7 pi over 4. So that tells me that x is 5 pi over 4, or x is 7 pi over 4. However, we're not quite done with this, because remember that in the unit circle, this 5 pi over 4 works. It satisfies giving us a y value of negative radical 2 over 2, but you're allowed to rotate around the unit circle multiple times. And so to take into account all the different answers, I need to add 2 in pi to both expressions. And what n stands for is an integer. And I'll remind you, the integers are the counting numbers, 1, 2, 3, 4, 5, 6, 7, etc. They also include 0, and they include the negative counting numbers. So by adding 2 in pi, we take care of all these full circle rotations that will also give us a value of negative radical 2 over 2 for the sign. And to put this in a different perspective, down here is a graph of the sine function. And if I try to find out where the sine value is negative radical 2 over 2, I might draw this line right here of negative radical 2 over 2. And you'll notice that the sine is negative radical 2 over 2 here, which is 5 pi over 4, here, which is 7 pi over 4. But it also occurs here, which you'll notice is adding 2 pi, here, which again you'll notice is adding 2 pi to that value, subtracting 2 pi's. So we have all these different answers, actually an infinite number of answers, and that's why we have this plus 2 in pi. Let's try another one. This time it involves cosine. So again, relying on all those algebra skills that I've got, I want to isolate the expressions involving x. So I think the quickest way is to subtract cosine from both sides, and we get to here. Again, I'm not going to go to my unit circle until I get just the trig function by itself, so I'll divide both sides by negative 2. And I end up getting positive radical 3 over 2 equals the cosine of x. So now I go to my unit circle. I need a positive cosine, so that's quadrants 1 and 4. And I need the cosine to be radical 3 over 2. And that is the shallow angles here and here. So this value, this first value, is pi over 6. So this is pi over 6 right here. And this value down here is, gosh, what is that? That's 11 pi over 6, right? So those are going to be basically my two answers. So I said x equals pi over 6 plus 2n pi. And now I have to write a second answer, which is x equals 11 pi over 6 plus 2n pi. But I'm not going to do that. Oh, no, 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 no. You see, Mr. Brath, he's too efficient to write out a whole second expression. You see, using my logic and my common sense, I think I can handle both of these positions in the unit circle by saying x is positive pi over 6 plus 2n pi, or negative pi over 6 plus 2n pi. Now, you're welcome to write both expressions, but, you know, if we can be efficient and quick and show off our understanding of the unit circle, we can write our answers in a much more efficient way. It's just up to you. It's personal choice. Let's try another one. Number 3. Ooh, it has a star. I wonder why. So this involves a tangent squared. So again, going back to my algebra skills, I'm going to try to isolate the expression involving just the x. So the first thing I did is I added 1 to both sides. I get 3 times the tangent squared of x equals 1. I'm going to divide both sides by 3, and I get the tangent squared of x equals 1/3. Now, this is not the tangent of x, it's the tangent squared of x. And I'm not ready to go to the unit circle because I've got to get rid of the square. Well, how do we get rid of a square? We take the square root of both sides. Ooh, that's why it has a star. Because I'm wondering if when you took the square root of both sides, did you remember to put this plus or minus? Because every time you take the square root of both sides, you have to remember that there's a positive and a negative answer. So this becomes the tangent of x is plus or minus radical 3 over 3. You'll notice I cleaned up my square root over here. Well, if you're a member of the shortcut club for tangent, you know that radical 3 over 3 is a unit circle value. And tangent is the slope. And it turns out that positive radical 3 over 3 for tangent is this shallow line. So is this. Negative radical 3 over 3 for tangent is that negative shallow line. So we end up having 4 values here. All the shallow angles are all the 6. So we can say x equals, we can list them all out. Pi 6, 5 pi 6, 7 pi 6, 11 pi 6, and don't forget we want to include entire rotations of the unit circle. So right there, that could be the way you express your answer. That's fabulous. You would get 100%. You know, unless you want to show off. And if you were fancy, notice the fancy font. I think you could do it without listing all 4. I think if you really put your mind to it, you could take care of this point and this point by using plus or minus. So that takes care of, what's that take care of? It takes care of the pi 6 and the 11 pi 6. So plus or minus pi 6. Now what do you do about these points over here? What about this point and that point? Well, what I want you to notice about like this point here is that is a polar opposite of negative pi 6. And this point here is a polar opposite of positive pi 6. It's a full semicircle rotation. Now we know 2n pi is an entire rotation. So what's a semicircle rotation? N pi. Again, I don't care which way you express your answers. You can list them all out and tack on your plus 2n pi, or you could be efficient and think it through. The only thing that I want you to be able to do is understand that these are the same thing. Because if you were given a question that was multiple choice, I'd want you to be able to recognize that these two things say the exact same thing. We've got another problem here. I'd like you to pause the video and try this on your own. And then when you have your answer, when you've gone to the unit circle, when you've listed your answers, and try to be efficient, try to be fancy, come back to the video and let's see what you got. Hey, welcome back. So when I isolated the cosine of x, I got plus or minus radical 2 over 2. If you got that, awesome. If you didn't, go back and make sure you can. So cosine is positive in quadrants 1 and 4. It's negative in quadrants 2 and 3. Radical 2 over 2 is the bisector, so I have those two positive radical 2 over 2, these two negative radical 2 over 2. There's my listing. That is your inefficient listing of pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths plus 2 n pi. But if you're efficient, if you look for the shortest, most efficient way, you could say, again, notice my fancy font, x equals positive or negative pi fourths plus n pi. And again, the reason why I'm doing n pi and not 2n pi is because I'm rotating a full semicircle to get to these polar opposites. I'm not rotating a full circle, just a semicircle half as much. Let's practice another one. Again, hit pause, try it, come back in. Okay, so this is what I got. I got all the way down to here. And the sine value is radical 3 over 2 at the steep angles. So sine is positive in quadrants 1 and 2. Sine is negative in quadrants 3 and 4. Again, you could list pi thirds, 2 pi thirds, 4 pi thirds plus 5 pi thirds plus 2 n pi. Or if you're efficient, you could be fancy and you could have this. So here's one, and this one I think we need to work through together. Anytime I have a squared term, I always try to get everything over to one side and factor. Now remember, the easiest way to factor is to pull out a GCF. So I'm going to pull out a cosine of both terms. So I'm going to take this cosine, I'm going to pull it out in front, and this is what I get. I get the cosine of x, which I pulled out. In this term, I'm left with a 2 cosine of x. In this term, I'm left with a minus 1. Now, if I have two numbers, and I do, I have this number and I have this number, and I multiply them to get 0, that must mean that each one of those numbers has to be 0. So maybe the first expression there is 0, or maybe the second expression is 0. Well, where is the cosine of x 0? Well, the cosine of x is 0 straight up and straight down. And over here, I have to solve this. I have to get cosine of x all by itself. So I added 1 and I divided by 2 and I got the cosine of x as a half. Well, where is the cosine of x positive? In quadrants 1 and 4. Where is the cosine of x a half? It's at the steep angle in quadrants 1 and 4. So what are my answers? Well, my answer here is this blue, these two blue lines are plus or minus pi thirds plus 2 n pi. Notice I went back to 2 n pi because quadrants 2 and 3 don't work. So I didn't want to do a semicircle rotation. I wanted to do a full circle rotation. Then for the red ones, I did pi halves plus n pi. And I chose n pi because, again, to go from here to here, it's a semicircle rotation, not a full rotation. So let's try this one. And this one, oh, that face is scary. So here's what I did. I got everything to one side, and I'm going to factor. And I'm going to factor this by taking a look here at these two terms and pulling out a GCF. And I think I can pull out a cotangent for both of these. So I pull my cotangent out, and that's what I'm left with. Well, again, anytime you multiply two numbers together and get 0, one of those numbers has to be 0. So I took a look over here, maybe that's 0. And I took a look over here, and maybe that's 0. The cotangent, I'm in the shortcut club. I know the cotangent is 0, straight up and straight down. This one I solved, and I got that the cosine of x is plus or minus radical 2. Wait a minute. The cosine of x can never be bigger or smaller than 1 or negative 1. This, no, this doesn't work. So my answer is simply pi halves plus n pi.